Welcome to a lesson with Dr. Powell. We're going to look at groups that preserve structure of digraphs. What is a digraph? Digraph is something that looks like this. It has vertices and edges that are directed, hence di for direction in the graph. So let's take a look at something like this, for instance. There are three vertices, and a graph permutation that preserves structure is one such that 1 to 2 is going to be sent to an arrow. So each arrow is sent to another arrow in a way that the visual structure of the graph is preserved. Things are just turned around a little bit, but locally everything looks the same. So 1 to 2 is going to be mapped to something like itself or 3 to 2. Those are the only options. Notice that 2 can't go anywhere but itself because it has two arrows headed into it. 3 can go to 1 since there's an arrow coming out of it and there's an arrow coming out of 1. So the local structure is the same and they can go to themselves. Kind of preserving the idea that f of 1 to 2 is the same thing as f of 1 f of f arrow, so the image of the arrow, f of 2, for the structure to be preserved, we need this to be happening, which is okay if this arrow is sent to that one from 3 to 2. So the group structure looks like something like mod 2 arithmetic, because either these can swap or either not. And if you compose this with itself, you get the identity. And identity with that is just itself. It really is mod 2 arithmetic. Now let's look at another example. Let's suppose that we have something like this. Maybe we have 1, 2, 3, and maybe then we have arrow in, 4, arrow in, 5. Notice that 5 and 4 can freely swap as a group element, 4 to 5. Also, we can have 2 and 3 can freely swap, and those are the only two things that can happen. Because of that, we actually get, since this is freely swapping independently of this happens like this, like mod 2 with this, but then since it's free, we can pair this or not this with 2, 3, all we want. Where this group corresponds to the identity and 4, 5, and this group corresponds to the identity and 2, 3. And putting these together, we can have freely, because these are disjoint cycles types, we could have, or disjoint cycles, we could have 4, 5, or 4, 5, 2, 3, or we could have 2, 3, or we could have the identity. Notice that there's 4 elements, just like there's 4 elements in here. This group is isomorphic to the group of permutations that preserve this digraph structure. Thanks for watching.